So last time we left off in the middle of section 13.1 talking about linear measure, and specifically we were talking about circles when we ended our discussion. We had taken a look at circumference and its relation to arc length, which is a portion of the circumference of a circle. And so we're going to do a couple of examples that relate those ideas together. So example number 8 says, if a circle has a diameter of 4 over pi centimeters, what is its circumference? So this one is a direct question about circumference. So circumference is either pi r, hang on, put the 2 there, 2 pi r, or the circumference is pi d. If it's actually giving you the r or the d, you can just pick which one sort of makes sense to use. Obviously, there's a relationship between these two equations we talked about last time, and that relationship is that 2 times the radius is actually equal to the diameter, so that's why that's showing up there. But since we're actually given the problem where we're told that this is the diameter, it makes sense to start with this particular equation this time. So our circumference is pi times the diameter, but the diameter is 4 divided by pi. So what's going to end up happening? Yep, the pi's are going to cancel out, leaving me with 4. Yeah, and if there are units given on the original measurements that you're using, you need units on your answers as well. There are on this one. It was 4 over pi centimeters. So my circumference will also be 4 centimeters. Any questions on that? Okay, the next question actually asks us to sort of go in reverse. It's telling us the circumference and asking us for the radius. So we need to use the equation that relates circumference with radius, which is circumference equals 2 pi r. But instead of it giving us r, like it gave us d last time, this time it gives us the circumference, which is on the left-hand side. So we need to fill it in the correct location. So this is 0.68 equals 2 pi and r. Now, contrary to radius's projection that pi is 3 1/7, we're going to use the pi in its full form that your calculator has, sort of stored inside of it. So make sure you're not plugging in 3 1/7 or 3.14, an approximation for it. You're actually going to use the pi value from your calculator as we do this. You can see that what we need to do is we need to divide this by 2 pi in order to get the radius r alone. You want to be a little bit careful about doing that, depending on what kind of calculator and how your calculator is interpreting what you're doing. You may need to put parentheses around the 2 pi, because what it might do, if you're not being careful, for example, the TI-83, if I try this with it in the older operating system that exists inside of it, it would divide it by 2, and then it would multiply it by pi because of the order of operations that it would understand you to mean. So the parentheses are absolutely crucial in this calculator, or it will divide and multiply in the wrong way. So if we take our, 0.68, and divide by the multiplication of 2 times pi, which is approximately 6.28, but we'll use the actual value, we will get that our radius is what? We'll go with 2 decimal places, it looks like I've been using. It's approximation. What did it give you? What do you have, Levi?
I don't know if I did it.
It's okay. What do you think you have?
Well, when I did it without the parentheses, it was 1.06.
Okay, and then what did tell us when you did with it?
It was 0.10.
That's the one you want. So yours needs parentheses. It was a 0.1 what?
It was 0.108.
Okay, so if I do 2 decimals, it would be 0.11, right? Yeah. So most of the time, if it's giving, well, not most of the time, if it gives you 2 different answers, it's doing what I suggested that it might be doing. So you're going to need those parentheses. So it is 0.11. What are my units of measure on this one? Meters, right? Because the original measurement was also given in meters. So we will go with 2 decimals of accuracy on all of our work. Any questions on that one? Okay, let's try an arc length question. This one wants to know the length of a semicircular arc. So what would a semicircular arc mean? What are we looking at if we're looking at a semicircle? What does that mean? Half of a circle, right. Now, there's an equation that we had for arc length from last time. Let me pull it up over here. It looked like this. And it said that the length, whatever we're doing, is pi r theta over 180. So I'm going to just write that down over here. My length is pi r theta over 180. So tell me what information we know in this equation in the problem. Emily, we know the radius. The radius is 1/2. So pi we know because it's a number. The radius we know is 1/2. Do we know theta? Do you remember what theta was when that was described over here? Say it louder. Yeah, it was the central angle. It was the measurement. Whoops, I was trying to get a highlighter. It was the measurement right here of that angle. So if we have a semicircle, what is the measure of our angle? 180, yes. Right, so a semicircle, I'll just use this graph to draw on it. A semicircle would be all the way here, right, from left to right of that yellow. It would be 180 degrees. So that's my theta over here. It's 180. Did I write it down wrong over there? Or do I have a typo in my notes? No, it's okay. I have a typo in my notes. Okay. And then if I divide by 180, what do you notice? Yeah, the 180s cancel. Even if they didn't, they could reduce, right? I mean, potentially so. So yeah, the 180s cancel. So I'm left with pi times 1/2. What would I need to do? Just evaluate in the calculator, right? So you can either type in pi and type times 1/2, or you can type in pi and divide by 2. What do you get? What is it? Somebody said it. 1.57 is right, yeah. 1.57 if you do that division. What are my units? It is, it's inches. Let me slide it over so I have a little bit more space. Inches. All right, let's take a look at another one. Number 11, what is the radius of an arc whose central angle is 82 degrees and whose arc length is 160 centimeters? So we're going to start out with the same equation that we did on the last problem. And somebody tell me what we know and what we can fill in or where it is or whatever. All right, so that's the L and this is the left-hand side, right, Emily?
Mm-hmm.
Okay, good.
And then theta would be 82.
Yep. And the radius, yeah, and the radius we don't know, right? So, yeah. Yep, so my 82 is the degree measure this time, and my length is my 160. So just a couple of different things you could do. There's lots of things you could do. I'm probably most tempted to multiply by the 180 and then divide by the 82, but you can do it in whatever order you'd like. So if you do 180 times the 160, the number gets quite large for just the moment. It's 28,800 equals, I still have my pi, my r, and my 82. And then we'll divide by 82 and pi, so it'll cancel both those. Again, be careful in your calculator that if you need parentheses on that denominator, that you do that. Oops. And we'll get an approximation because we're going to have to round. If I use 2 decimal places, what will this approximation end up at? Yes, 111, 80 tenths or 80 hundredths. And what are my units? Yeah, centimeters. Just go back to look at your problem for whichever one it is and the one you're working on. Any questions about those?
So on every problem in the homework, they want us to round to the second.
Yeah, we'll always round to 2 decimal places. The only time that might not be the case, Julie, is let's say, for instance, the first 2 decimal places are both zeros. Then you might need a third one for it to make sense. And it doesn't happen very frequently, but every now and then something like that will pop up. But 2 decimal places otherwise. All right.